Hi everyone. So I think we're about ready to get started. Let me do a quick introduction first. So my name is Rob Miles. I'm a senior engineering manager at Etsy, and I lead the machine learning platform team, which is one of a couple of teams in a broader organization that essentially builds all of the machine learning infrastructure, platform, and systems for Etsy. And Kyle, do you want to introduce yourself?
Yeah, absolutely. Hi, everyone. My name is Kyle. I'm an engineer on Rob's team, and I specifically focus on the model serving part of the platform, focusing on real-time inference.
Cool. So the talk we have for you today is based on a blog post that was published on Etsy's Coders Craft website. Kyle's going to drop the link in the chat now. For those of you who haven't had a chance to read it, you can check it out after the presentation. This is going to be a relatively short presentation, so we wanted to leave time at the end for any questions you might have, any discussion. And let's jump in. So let's set the scene first by talking briefly about the main use cases for machine learning at Etsy. Like most e-commerce companies, the biggest teams that are applying ML are in search, recommendations, and advertising. Etsy has a fairly unique problem to solve. We have an inventory of millions of items, have very little structured data around them. So we're not like Amazon, where you have a product SKU and you have a whole bunch of structured information. Often things that's for sale on Etsy are individual unique pieces of art that are created and then listed. And we have very little to go on when trying to connect a buyer with a seller. And so a lot of the ML is aimed at trying to make sense of that, aimed at ranking the listings according to like search terms that have been entered or things that we know about you as a buyer. We've also got increasing usage of ML now in the trust and safety space, so things like detecting bad actors on the marketplace or violations of policy, and also in providing better tools to our sellers. And the ML platform team is made up of two squads. Like Kyle said, he's on the model serving side, and then the other squad that we have looks at training and prototyping. And so that's kind of the scope of what we're talking about when we talk about the redesign of the ML platform, is improving the training and prototyping experience and the online serving experience. So let's talk a little about the journey of Etsy's ML platform. And it really starts about 2017. Like before 2017, machine learning models were getting created at Etsy, especially for making product recommendations to our customers. But those models were exclusively batch inferenced. And more importantly, the scientists creating them had to build pretty much all of their infrastructure from scratch. There was no platform. In 2017, Etsy acquired a company that was specializing in the search ML space. And with it came a need for a step up in the number of ML models, a need for online serving of those models. And there was just generally a recognition of the value that a platform can add in allowing scientists to focus on where they add the most value on the modeling work. So the first version of Etsy's ML platform had a few interesting characteristics that I want to talk through. Firstly, all of the core components were built in-house. So at that time in 2017, there were very few open source frameworks and tools available. Secondly, the ML framework that underpinned the platform did have sensible design principles. It was flexible, it was framework agnostic. It looked to define high-level interfaces and then provided common functionality like model versioning and packaging. It was built at a time, when Etsy was just starting to migrate to the cloud. So it was kind of adapted to the cloud in its infancy. So in 2017, Etsy was in in-house data centers. So ML at the time involved kind of designating compute resource on machines, using spreadsheets to control that. But quite quickly in the infancy of this platform, we moved to Google Cloud, and we were able to start offering like elastic compute to the growing data science team. Let's talk a little bit about some of the pain, though, that people started to feel. So those characteristics that helped the platform serve Etsy pretty well for several years did start to become a cause of pain to our users. The fact that everything was built in-house meant that new hire data scientists had to spend weeks learning these in-house frameworks and systems to be productive. And it's not particularly top of anyone's list to learn in-house systems that can't go on your resume or whatever. And also, as the available open source and cloud frameworks matured, more scientists expected to be able to use those same tools that they were familiar with from college or from previous jobs. Secondly, while the in-house framework had good design principles, it was a large monolithic code base. And over time, a lack of good engineering practices in that code base started to slow down development. And moreover, scientists became dependent on the ML platform team to be able to experiment with new ML frameworks, which started to slow down innovation. And thirdly, it wasn't designed for the cloud, so it couldn't take advantage of the increasing number of ML services available to us via Google Cloud that could help to accelerate provision of new capabilities. So all these pain points led us to kick off a project in 2020 to redesign the platform from the ground up. So one of the first things that we did was to form a working group of scientists and platform engineers and agree on the architectural principles that would underpin the new platform. And we agreed on like a number of principles, around 10 or so. I'm going to highlight 3, which I think are the most important. The first was that we made a decision to build a flexible platform like the old one, but to build first-class support for TensorFlow. So there was a growing consensus at Etsy that TensorFlow was the tool of choice for many or most ML applications, and we wanted to be able to take advantage of its native tooling. However, there was also concern about putting all our eggs in one basket, so we wanted to make sure that the platform continued to be flexible enough to support other ML frameworks. Secondly, we made a decision to build for Google Cloud. We decided that the risk of Etsy moving away from Google Cloud in the near future was sufficiently small that we didn't really need to worry about vendor lock-in, and instead wanted to take advantage of Google's managed services wherever it made sense. Related to this, we also decided that we would only build in-house if there was nothing available on Google Cloud or in open source offerings that met our needs. And thirdly, we decided we needed to be careful with abstractions. So our power users were particularly clear that they wanted direct access to the tools and frameworks. And we agreed as a principle that we would be very careful in creating any abstractions that could slow those users down or constrain them. However, as we pursue a goal of democratization of ML, we do also recognize that we may need to create some abstractions to help less proficient users. Okay, over to Kyle.
Cool. Am I going to take over the screen from you?
Yes.
Great. 1 second. Awesome. So I'm going to jump in and talk about the actual V2 machine learning platform that we built based on the architectural principles that Rob just outlined. So let's start with the training and prototyping part of the platform. Our training and prototyping platform largely relies on Google Cloud services like Vertex AI and Dataflow. So customers can use Dataflow for very large ETL jobs, and Vertex Notebooks or Vertex AI for rapid prototyping and production training of models on more complex infrastructure like GPUs. In accordance with our principles, our training platform is built for Google Cloud and limited in its abstractions. Customers can leverage all of these cloud services directly using Google-supported documentation, which limits the amount of technical debt our team accrues over time. This also gives customers access to the latest Google Cloud features without introducing our team as a blocker or a limiting factor, which is really nice. Moving on to model serving. So using our in-house model management UI, Barista, users can create stateless ML microservices on Google Kubernetes Engine. So we support TensorFlow model artifacts using TensorFlow serving, open source, served via both REST and gRPC, and any other non-TensorFlow models using the Selvin Core Python library, which allows users to customize their inference code and a Docker image to their use case. One notable addition to our new infrastructure over our old in-house framework was gRPC, which allows for more efficient serialization of payloads compared to JSON and REST. Our serving platform is very TensorFlow first with limited abstractions, using all features supported by the open source TensorFlow serving. However, we also wanted to give users the flexibility to serve any model artifacts they wanted through Selvin. Although Selvin might not be the ideal place to serve something like a PyTorch model compared to something like TorchServe, which would be more native, Selvin gives users the ability to serve models in any framework and make the business case for future support of more framework-specific serving solutions, such as TorchServe, TensorRT, or anything else that they want to use in the future. So to top tie all of this together into schedulable production workflows, we use Vertex AI pipelines on Google Cloud. So this allows our users to write DAGs using either the TensorFlow Extended, TFX, or Kubeflow software developer kits, SDKs, and then run these workflows on Google managed infrastructure. Typically, we automatically retrain models daily and then redeploy them to production via our model management service, Arista. Again, this approach is very TensorFlow and Google Cloud first. However, in contrast with one of our design principles, we're beginning to selectively introduce abstractions, like layers that allow data scientists to use Python instead of YAML. The important part here is that these abstractions are carefully introduced based on justification, as opposed to being written prior to having any significant business justification or sort of user pain. So what are some outcomes that we saw from our redesign of our training, serving, and workflow orchestration platform? So far, we've seen roughly a 50% reduction in the time it takes to go from idea to experiment. This is a relatively common KPI in the ML platform space, and we aim to continue reducing the time it takes for data scientists to test new model configurations against existing ones. Note that here, I'm just talking about not the time to production per se, but the time to live experimentation, which would be like an A/B test, comparing a new model version versus an older one. Additionally, a single product team was able to complete 2,000 experiments in Q1 of last year, which is a significantly improved number from an estimated 50 experiments per quarter on our old in-house platform. The number of iterations ML practitioners can conduct is often proportional to how quickly they can improve our models and we can drive value. Finally, the ability to prototype completely new model architectures, not just new hyperparameters or new features, quickly has led to an explosion of more novel modeling techniques and model improvements making their way to both experimentation and production, which has been huge for the leaps and bounds we're making in the ML space. But what were some challenges and learnings? It definitely was not all smooth sailing, and I think we're continuing to learn today. One of the big things we've had challenges with is adoption, primarily that it's been slow. There's lots of inertia in the old way of doing things on our platform, and a greater portion of ML practitioner time is spent iterating on existing models rather than designing completely new models or new workflows. However, early adopter success stories and power users who are already migrating workflows are reporting large productivity gains in things like TensorFlow, Vertex AI, and Kubeflow, which has been really great for the platform. Secondly, more decentralized ML code has been a challenge. So the enhanced flexibility of model training using all of these platforms as they're meant to be used works well for some teams. But for other teams with less resources, there's sometimes a struggle where they want clearer guidance or expert level support on Google Cloud services and open source tools from our team. While being Google Cloud and TensorFlow first has worked well in some places, sometimes it drains our own team's resources when we're expected to take ownership or consult on ML-specific issues that are outside of our primary domain. For instance, we're often consulted for unexpected performance issues in model serving, as increasingly large deep learning models are served on our platform using TensorFlow. Lastly, we've really been learning to think of our platform as a product, keeping folks in the loop via office hours, announcements, and helpful evangelists on various teams. Promoting our new platform internally helps improve the tools we provide, increase adoption, and drive success for both machine learning and the business at Etsy. We're continuing to improve on our ML platform beta today and look forward to more interesting and useful additions. And that is the end of the presentation as it is, but we would love to take any questions that anyone has on the call, if there are any. Seriously, anyone feel free to ask anything you like. That was all we prepared, but we wanted to leave it open for just open discussion if anyone has questions about anything you just saw or Etsy as a whole in terms of machine learning. Thank you.
Okay, Q&A. Why Seldom, why not KF serving?
We did an evaluation of a bunch of different serving platforms at the time. if I recall, since this was like a year and a half ago, I don't remember where KF serving was at, but we really wanted users to be able to just like write like simple model inference code in Python, and Selvin core, the Python library seemed like a nice way to do that. But honestly, I'm not familiar with where KF serving is at today in regards to maturity.
I think it was on our list of products we evaluated, right? But
Yeah.
I can't quite remember now what specifically discouraged us from it.
Yeah. What are you using for model monitoring, and do you have a user feedback mechanism in place?
So when we say model monitoring, I guess one question is, do we mean observability from an infrastructure perspective or from a ML perspective? So from an infrastructure perspective, do you want to give an overview?
Yeah, absolutely. So since we serve everything on Kubernetes, a lot of our actual performance monitoring is done just via Prometheus and Grafana dashboards. If you're talking about model monitoring, probably more as it relates to this conference, we're still in the process of figuring out kind of our model drift and model observability solution. In terms of user feedback mechanism, I'm not 100% sure what you mean by that. If you mean like, do you mean data labeling or something else, Nick?
We can come back to that one if Nick gets a chance to reply. But in terms of user feedback, I mean, if it's sort of feedback on the platform, then we do have product managers now that we're working with who have been conducting some more extensive like user research across all of the infrastructure space that's giving us feedback there. Data labeling is what you meant. Okay.
Yeah. So for data labeling, it really depends on the use case. As you can imagine, at Etsy, a lot of our machine learning is around search, ads, and recommendations. So in those cases, we're lucky enough to have kind of automatically labeled data where a user clicks on an item or purchases something, we can use that as training data. But yes, for things like trust and safety, where we're trying to say like flag problematic listings, there is kind of human in the loop situations where it does undergo human review.
Cool. What capabilities do you have that allow users to increase experimentations, especially in non-TensorFlow environment?
Yeah, that's a good question. I think like speaking for the training side of the team, I would say our philosophy on that is really just allowing users to have just kind of free reign in the Google Cloud environment using Vertex notebooks or like Vertex AI platform itself. Users can essentially do whatever they want with whatever compute that they want. So they can essentially iterate as quickly as they want in the cloud with infrastructure that they need using any image or environment with any modeling framework, since Vertex itself is not TensorFlow specific. When it comes to serving, we of course have a pipeline for taking that model to production, but for experimentation, they're relatively uninhibited.
Any other roadblocks that we encountered that weren't discussed that are worth mentioning? Well, one I could speak to was there certainly was some like negotiation needed from an architectural perspective when we came to want to introduce Kubeflow pipelines to Etsy, because there's a separate data engineering team at Etsy, and that team already owns and operates Airflow, which is used for ETL workflows. And so there was some concern, and we had some like a fair amount of discussion about whether it made sense to like introduce Kubeflow pipelines as well, which is playing in a very similar space. And we felt very strongly that Kubeflow pipelines could offer additional benefit to ML practitioners over the use of Airflow. But that was certainly something that we had to discuss openly and make sure that we all felt comfortable that it was the right decision for Etsy.
Yeah. From Div, how do you see the platform growing over the next year? That's a good question for you, I think.
Yeah, I mean, Etsy is growing, so the scale of the problems that we're dealing with is definitely growing. We're finding, especially in model serving, that we're dealing with some of those problems at scale more and more, right? Like we're actually finding ourselves at the cutting edge in some cases of like the knowledge of how gRPC works at a low level, for example, compared to other teams at Etsy. For example, search requests coming into the search team can fan out to sometimes like 20 batch requests to our ML platform, which means that we can be operating at 20 times the scale of the search platform, which is already operating at a reasonable scale. In addition, like other ways we see the platform growing, I mean, a lot of our investment is around DevX. So it's about improving the data scientist experience on the platform, really understanding like their pain points, figuring out like how do we make all of our systems play really well together. I think there's Etsy is a little immature in terms of having a kind of centralized UI, something like Uber's Michelangelo type thing. We don't have that right now, so there's a lot of investment and thought going in that kind of area.
Yeah, cool. And from Jacqueline, to follow up on Selvin, has Etsy explored using BentoML that allows you to write simple Python code? And the answer is yes. BentoML was also part of the evaluation that we did when we were picking a non-TensorFlow serving framework. Selvin Core outperformed BentoML in our initial performance tests. And I forget if at the time BentoML offered a gRPC protocol for actually making inference requests, which was also something that was a nice to have on our list. So we looked at Bento, but ultimately chose Selvin Core.
Has Etsy done much with computer vision for customers to be able to do a reverse image search for products they love but can't describe? Yeah, computer vision is a nascent area at Etsy, but I think that we see a lot of potential there, and there is like a computer vision team now that's doing a bunch of research into lots of different applications of CV.
Yeah, and I believe specifically they are looking at all kinds of different embedding-based sort of searches that you can do within that space. What kind of automation for ML training, testing, and deployment have you built into the platform? So automation for ML training kind of goes back to the workflow orchestration that we talked about. So folks still use Airflow at Etsy for some of the automation around the training and deployment. We can also, again, offer Kubeflow pipelines or TFX for that now in terms of actually writing a schedulable DAG to automate that. Testing would probably be up to the individual teams themselves. We do have some tests that run to confirm that a model, say, like makes the same predictions at inference time that it does at training time. But in terms of the actual model code, data scientists would be responsible for writing their own test cases.
Yeah, I would say that in general, testing is probably not our most mature area. There is potential for us to do more there.
Yeah.
Okay.
Yeah.
Any more questions?
If anyone else thinks of anything, I believe, like Maggie said, we're both in the Arize Slack. Feel free to ping us directly or publicly, and we can kind of discuss stuff there. Happy to share more about stuff we're doing at Etsy.
Definitely. Cool. Okay. Well, thanks very much for all the great questions. It was a pleasure to present to you. And as Kyle said, feel free to. Oh, okay. One last question. We can do this one. What winning points did you communicate to win over the data engineering team on migrating from Airflow? Well, just to be clear, we didn't migrate from Airflow. We're offering Kubeflow pipelines as a separate offering, and so really, data scientists can choose actually if they want to write their pipeline in Airflow or in KFP. So I think in terms of how do we convince them? I think we kind of made the case that there was enough interesting stuff there in KFP for us to try out this as a separate offering, and that ultimately the users would decide in a sense about which they preferred to use. And if it turned out nobody was getting value from KFP, then of course we would take that feedback. Yeah.
And the last question, how do we detect model drift? Going to be a little ironic for an ML observability conference, but we're a little naive in that space. I would say currently we don't, unless data scientists individually look at it in regards to their training data. But it's something that we're hoping to tackle this year and very soon by implementing more comprehensive ML observability.
Yep.
Cool.
Okay.
Awesome.
Okay. Thanks, everyone.
Thanks, everyone. Have a good one.